Okay, so in the previous video we kind of talked about enamines and wrapped up some ideas about reacting with the alpha, reacting with the alpha hydrogens there. And so we want to kind of continue on with this and talk about some specific reactions, um, and to kind of carry on and say, what else can we do with these? So let's go back and talk about Claisen condensation here. And remember, a Claisen condensation, we're basically uh, just using an ester and forming a new dicarbonyl compound at the end of it, right? So a Claisen condensation is going to look something like this. Let's say we take our good old buddy ethyl acetate and let's react it with another ethyl acetate. And so important point, right? We've got to generate the enolate, right? So we need to put a strong base. And remember, to prevent side reactions, right, we got to put basically that base there from the ester, right? So whatever is on the ester is going to be our solvent of choice and our base of choice there. Otherwise, we're going to, form some other reactions there. And go back to chapter 21, right? And I believe chapter 21, yeah, is where we first talked about esterification there, right? Swapping one ester group out for another one there. But anyway, so we pick the right base, and then we can do this reaction, right? So let me just get rid of those dots there. Cool. All right. So base is going to attack, right? I don't know. Let's start with the green one. Doesn't really matter. So base is going to attack the acidic hydrogens, right? Right. To set up the enolate, right? So we could follow those red arrows here. We'll do that real quick just for recap's sake. All right, so that is what would happen here. Right, we'd end up with our enolate, although remember, equilibrium is really going to favor, kind of the, the ketone, not the ketone, the ester, right? But remember also to, what is going to be useful for us in terms of reactivity is, to just work with this resonance form here, right, where we have the alpha carbon with a negative charge, right? So yes, it's stabilized, yes, we have to worry about equilibrium, all this kind of stuff, right? We're not ignoring any of that. We're just saying, hey, this forms to some appreciable amount, an appreciable amount that's enough for a reaction to happen, right? And so that's what we care about. So we've got that negative attacks positive, and whoops, that wasn't a very well aimed arrow. Negative attacks positive, and a shocking change, right? A sarcastically shocking change. So let's see what happens here, right? So we have this, right? We've got that. We kicked up negative charge, right? There it is. We bound our green ester, right? So this is what happens after that first step. We want to reform our carbonyl compound, so we slam down a pi bond, kick off the best leaving group, right? And so after all this, I'll try and draw it in the same way that it's oriented here, and then I'll come back and clean it up. Let's see how this is going to look. All right, so there's that, right? But that looks goofy, right? So let's just clean that up. There's this. Fantastic, right? So here's what our product would be out of all this, right? So this is our quintessential Claisen condensation there, right? A couple things to pay attention to, right? Pay attention to the base. If you aren't doing, if you have multiple esters, you're going to make multiple products, all that kind of stuff along the way, right? Okay, so let's take the ideas here, right, with the Claisen condensation and go on to just a generic Aldol condensation, right? So an Aldol condensation is going to work essentially the same way, right? Except now we're going to just, let's use acetone. acetone plus acetone, and let's put in some kind of base, whatever, right? We can use pretty much any base we want to. Let's use aqueous hydroxide conditions, and let's heat this up, right? Let's heat this up now, okay? In fact, we want to heat it up above 100 degrees Celsius, typically, right? Typically above 100 degrees, and that's going to be important, right? So let's heat this up. Let's walk through and see what's going to happen here, right? I'm just going to start to shorthand this a little bit, right? So we generate our, let's say, nucleophilic alpha hydrogen, right? Let's call it that. All right, so just this itself, we end up making this here. So far, so good. So far, so good. Negative charge. Here's our buddy in blue down here, and we sent out a yellow bond to that carbonyl carbon there. Okay. So let's take care of it, right? We don't, here's big difference number one, right? We don't have a good leaving group, right? We don't have a good leaving group. So we can't really slam down a pi bond. We're not going to kick off carbons, right? You know, that's not going to happen. So we don't have a good leaving group, so we're kind of, let's say, stuck right here. So that negative is looking for something to help out, right? Let's send in some water, right? And let's just make this look a little bit nice and neat. So let's do this, 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 right? We made a bond in yellow to our buddy in blue. Okay, so I just kind of twisted things around, made it look a little bit nicer. And so now we start to heat this thing up, right? And so what's going to happen in this case is we're basically going to make water and kick it off, right? So here is how this is going to work. Now, we're going to do something shocking. We're going to find an acidic hydrogen, and we just happen to have an acidic hydrogen right there, and we've still got some really strong base around, right? And as we start to heat this up, right, acid is going to attack base. So acid attacks here, here, and here, okay? So let's follow these arrows, right? So here, here, we had our original bond in yellow. We slammed down a pi bond, right? And we drove off some hydroxide. Well, let me do this in color here so we can follow along with everything, right? We drove off some hydroxide. Sorry about that. I'm working towards the edge of my screen here. And so sometimes some of that accidentally slid that stuff up there. So we drove off that, and we ended up making water along the way also, right? So we had our original green hydroxide there, picked up our yellow hydrogen, okay? So we ended up driving off water, which is kind of why we need to heat this up. We also kicked off a hydroxide, which is not a good leaving group, right? That's just not really a good leaving group. But we are under basic conditions and all this kind of stuff, right? So we heat this up and we can get this to work. And so we end up forming, right, an alkene, right? An alkene that's kind of next door to our ketone right there, okay? So we have some, we end up generating this new kind of, let's say, functional group right here where we have an alkene that's next door to a ketone right there. So a couple of quick points here, right? We've got to heat this up to drive off the water. We form an ene-one, right? An ene-one, double bond ene-one, right? Ketone. And it's important to recognize that we're always going to form this generic group right here, right? The double bond is always going to be in, it's always going to be conjugated with the ketone, right? So we have a conjugated pi system. Remember, that's a very stable system, right? So there's a good driving force to generate this right here, right? So this is the important thing to remember from, or this is our aldol condensation, right? An aldol condensation where we're bringing two ketones together, right, to make that guy right there. And then if we take that aldol condensate product, right, and then heat it up, then we eventually drive off water, right, and we form our unsaturated enone down here, right? So basically, if we take an aldol condensation and then heat it up, we end up with this guy right here, right? So we're following the same mechanism that we've seen in a Claisen condensation, but now we're just, we're ending up with a different product down here. And in the next video, we'll talk about what we can do with these enone products, right? With these enone products. So, all right, we'll pick it up in the next video then.